Hello everyone, welcome to our webinar with Curation, where we'll be looking at the very exciting work that's going on to track the cost of lithium-ion batteries and to understand the dynamics and drivers behind market and technology shaping trends. I'm Andy Colthorpe, editor at Energy Storage News. When we launched the site in 2014, the world was a very different place. We can all remember dozens of things that have changed since then. Some good, some not so good. From an energy storage point of view, the adoption of batteries for the grid was at a very modest level back then, but there was a growing recognition that the lithium-ion batteries technologies that were revolutionizing consumer electronics and beginning to revolutionize transport would have a role to play in the energy transition. Back then, battery storage was throttled by the lack of regulations and policies that could support its growth. And another big barrier, of course, was cost. From there to now, we're in a world where the cost of battery storage, largely helped along by the growing excitement around electric vehicles, has fallen to the point where it makes economic sense in so many applications relating to the modernization of the electricity sector. The US and UK have both exceeded the milestone 1 gigawatt mark for grid-connected batteries, and the majority of this new capacity is lithium-ion. This is all very good news, and more than 1 million of you are visiting Energy Storage News each year to find out which projects, markets, and applications are of most interest to your customers, investors, and fellow stakeholders. But we do, at this point, have to acknowledge that a lot of important questions remain about where the battery industry goes from here and how those in the power sector can best leverage the experience and knowledge of the past few years. Questions about sustainability, stability and security of supply chains, about safety and technological innovation, and ultimately cost remain. For all of the good news, we also have to accept that the energy transition is going quickly in some areas, but nowhere near quickly enough in many others, if we are to have a chance of beating the worst impacts of the climate crisis. In short, both the challenges and the opportunities are huge. In today's webinar, we'll be learning from McKinsey Company experts Nicolo Campagnol, Jakob Fleischmann, and Marcus Wiltaner how they've helped Curation to build out the battery cost curve, which can answer many of the big questions. From what I've seen so far, the work they've done is fascinating, and I'm looking forward to this session, as I hope you all are. We begin now with a short explanation of the cost curve from Curation's Head of Energy Content, David Pratt. After the presentations, we're going to have a panel discussion with the experts, and you'll have the opportunity to ask your questions at the end. Please do put your questions for the speakers into the tab on the right-hand side of your screen, and we will do our best to answer as many of them as possible. And with that, over to you, David.
Thank you, Andy, and thank you everyone for attending the webinar today. My name is David Pratt and I am the Head of Energy Content at Curation. We are a business intelligence service tracking and identifying disruptive trends across energy and sustainability for our clients. Some of the world's largest businesses rely on us for consistent information and analysis that can deliver easy to digest and actionable insights. Battery storage falls squarely within our coverage due to its fast-growing trajectory and sustainability implications across the energy sector and beyond. With this in mind, we developed the battery cost curve with analytical support from our friends at McKinsey. The model tracks cost contributors across the battery supply chain, from raw materials and pack technologies to manufacturing capacity growth, to inform predictions on where costs are headed. It addresses some of the key players in the space and how their businesses are developing, along with the challenges and opportunities they face, and how market dynamics impact cost as the world moves towards electrification. The cost curve offer is designed to keep businesses up to date with the latest trends within the battery world and is available under 2 levels of access. Twice yearly updates of the cost model are available via a webinar with McKinsey, while companies wanting to go even deeper can get full access to the cost modeling and the battery experts behind it. All of this supports Curation's wider services of curated content, which includes a bi-weekly battery intelligence briefing, delivering insights on the latest developments in battery demand, supply, technology, and raw materials. I'd like to hand over now to our friends from McKinsey, who will explain in greater detail what Curation's battery cost curve offers.
Excellent. Thank you, David and Andy, and thank you all for joining us. My name is Markus Wilter, and I'm a partner with McKinsey based out of Vienna and Brussels. We have a small team of our battery experts here on the call with us today. From Brussels is joining Niccolò Campagnol, who is one of our battery materials experts, and Jakob Fleischmann from Munich, who is an associate partner who serves large battery makers and battery material makers and OEMs around the world. We are excited to talk a bit about our perspective of what is happening in batteries. I mean, many years ago, this was a nascent industry, an industry with a number of players and big ambitions, and we now see the scale up at an unprecedented scale. This scale drives down costs. This scale has allowed us, and this cost down has allowed us to use more batteries than ever imagined before. And many of the most ambitious outlooks from a few years have been surpassed many times. So what we're trying to do is working with clients around the world to understand these trends, these shifts, these paradigm shifts in the industry. And to get a bit closer with analytical tools to understand how will that impact costs going forward. Now, of course, we don't have a crystal ball. We don't know what the future will bring, but we have lots of tools that can help us to understand how costs will develop, depending on how technology will develop, how supply and demand will turn out, how raw materials will be available, and how this will all be regulated by governments. So maybe just as a backdrop on our work, as I said, we do work with clients across the whole battery value chain, everything from the people that make the materials, that dig out the materials out of the ground, to recyclers, to people that turn those into advanced materials, into cells, then package those into systems that get shipped to customers, and then to those customers that use batteries in all the different applications, from mobility to stationary to consumers. As part of this work, we have built up a set of proprietary assets, models, and databases. One of these models we have built for Curation, which is our view on how costs in the battery industry will develop, not only from an overall level, but also by factory, player by player, being able to differentiate and understand what's the cost curve in the industry rather than just a cost outlook. We are now a team of about 170 people globally working in this space predominantly. And that means we have a global team which can look at the trends in different places around the world. But we also have a team with very diverse backgrounds that can analyze all different kinds of the value chain and aspects of the battery industry. And we try and seek to connect and convene clients. This industry is also changing in the way companies are working together, academics are working together. So we are associated and we help to create some of these connection points and convening points. And we're working with the World Economic Forum, for example, on getting also the industry together around topics of sustainability. But enough on our background, let us jump in. The way we have organized this today is to start with a number of hypotheses of how we think the world will evolve, and we'll provide a little bit of background around each of those. And then we're looking forward to the Q&A to answer the questions.
Thank you very much, Markus. Please let me introduce to you the 6 hypotheses we prepared for today to closer look at together with you. The first one, we see that stationary energy storage systems actually need bespoke pack solutions for each of the different applications, but we also believe that stationary energy storage systems greatly benefit from using mass market cells as components, such as the cells from the electric car application. Secondly, we observe that the cell manufacturing is absolutely moving to where the demand is moving to Europe, is moving to the US, but still China will be the powerhouse of cell manufacturing. Looking at the raw materials, where there's a lot of discussion around, will raw material be constrained? Will they actually move the industry? While suppliers of some materials could be temporarily limited, we do not see this problem to really constrain the growth of the battery industry as such. And looking into what kind of chemistry will be on the market and will actually have what kind of market share, this is absolutely linked to the raw material supply. And not only because of this, we see that lithium iron phosphate is a battery chemistry that will sustain, that will stay on the market over the coming years, let's say over the coming decade, and that is very well suited for stationary storage applications. And also linked to stationary storage applications, we think that Second Life has a potential in this segment, but to make it an actual financially viable business and to really compete with the cost improving new cells and new batteries, it requires scale, it requires modularity, it requires smart product design, and it requires optimized logistics and optimized business setup, in fact. And as the sixth hypothesis, we believe that with clean energy in a net zero manufacturing setup and with recycled materials, there is the potential to actually reduce the CO2 footprint in lithium-ion batteries by up to 80%. Looking into our first hypothesis around the use of mass market cells in stationary storage applications, we would like to first look at the overall market development. We see that over the coming decade, the battery business, the manufacturing of cells following the demand, is actually growing by a CAGR of 30% year on year, and then following on from 2030 to 2040 at about 10% year-on-year growth, with the biggest segments, so the segments that drive the growth here, being passenger car applications, commercial vehicle applications, so all the mobility, but that also stationary storage and other applications, other mobility applications, for example, off-highway maritime, will have by 2040, 10 and 17% of the market, of this very large market then respectively. Because for 2030, we are looking at almost 4 terawatt hours in battery demand. For 2040, we're looking at more than 10 terawatt hours in battery demand. And the question is now, why would stationary energy storage benefit from using mass market cells? And the dynamic is actually in the pricing and in the procurement. We see here a cost curve that goes from 1 to 20 gigawatt hours of annual capacity of a manufacturing plant, of a lithium-ion cell manufacturing plant. And we see horizontally the willingness to pay that we observe in the different segments. So commercial vehicles here being at about $92 per kilowatt hour, stationary storage being lower at 85, and passenger vehicles being actually at about 77 US dollars per kilowatt hour projected to 2025. The fact that now stationary storage has 2 elements in it, first of all, quite a price pressure on the cells, but secondly, also not yet the same scale as passenger vehicles, makes it, looking at this cost curve, quite beneficial for stationary storage applications to actually tap into mass market cells that are coming at lower cost and applying them in tailored, in bespoke battery systems to each specific application in the segment. And there are actually 5 key dynamics that we see shaping the markets for battery packs across the different end-use applications. The first one being that the battery market, the battery business is growing across segments. Fast progressing electrification, for example, for the high volume segments, passenger cars, commercial vehicles, but also that the former niche segments develop into, from today's perspective, volume segments. Secondly, insourcing is happening in the volume segment. So OEMs, volume OEMs, insourced the pack production and are now, we can observe this from many different players, now move also closer and closer and more into the cell manufacturing. Though smaller players who do not have the scale to actually insource the pack manufacturing, the cell manufacturing, will still benefit from external vendors, external engineering companies providing those pack solutions, producing those packs. Thirdly, there are new bespoke niches also entering the market because of moving towards electrification. One good example is maritime applications. And we see an increased modularity. We see this happening on the market. We also see the need to actually then serve with standardized cells those different new applications, rather the smaller segments on the market. And we see an evolving player landscape. And here we actually see 2 dynamics. We see on the one hand side, small players, innovative players entering the market, looking to grow. But we also see a consolidation of the market as size is super critical for competitiveness on the cost side. And that, of course, incentivizes to consolidate. This page shows us how actually the niche segment of today becoming a large segment of the future. You see for the passenger cars here on the upper left side, 140 gigawatt hours of annual demand in 2020, 2,400 gigawatt hours of annual demand in 2030. You see, for example, for stationary storage, 15 gigawatt hours of annual demand last year and 170 gigawatt hours of annual demand in 2030. So the stationary storage demand of tomorrow is larger than the biggest segment today. Looking into our second hypothesis, where is battery manufacturing happening? Where is cell manufacturing moving? We are seeing a clear trend of cell manufacturing moving where the demand is. So now, after the fast growth in China, moving towards Europe, moving to the US. We see a growth of 50% per year in Europe. Over the coming years, we see a growth of 40% in the US, 40% growth of battery manufacturing a year on year. And we also looked at this from a cost side and actually compared what are the costs differences between US, EU, China, as you see here on the chart on the right side. And due to the high automation, due to the relevance of raw materials, due to the comparatively low relevance of factor cost, the difference is actually smaller than 10%. So that really incentivizes, let's put it that way, to have a regional for regional, as we call it, production, have rather shorter supply chains and move the manufacturing of cells where the demand is.
This moves takes us to the third hypothesis. Is there enough raw materials, or are we going to see any issues for this huge growth? And if we look at the commodities that are most touched by batteries, we see here a list of them. We have cobalt, lithium, we have nickel, manganese. Some of them are more impacted than others, and this means that these markets are going to be particularly affected by the speed of growth of the battery industry. And this opens the possibility of having, even if maybe timely, not necessarily in the long term or systematic, some mismatch between supply and demand, leading potentially to high prices. And this is the case for cobalt, this is the case for lithium. If we see nickel in total, the general market is not particularly impacted by batteries, not even in the future. But nickel is divided in two markets. It's class 1 and class 2. And class 1 is indeed very much depending on the growth of batteries. So what can we read out of this? What's important? So one of the ways that OEMs are trying to fix this is by either go aggressively into sourcing, so upstream integration or investment or having good contracts, or even opt for substitution when possible. And that would be the case of cobalt-free chemistries, as well as LFP as a nickel-free, as well as cobalt-free chemistry. And let's remember that the cure for high prices is most often not high prices. So a high price of any commodity in a stable way will incentivize miners to invest in new projects or to accelerate the go-to-market of other projects. And since we are talking about nickel, and I was telling you that nickel is actually divided in two, the market, you have on one side nickel class 1, which is a high purity, 99% pure nickel, and on the other side, class 2, which is normally connected to the production of iron. So normally it's iron and nickel together to produce stainless steel. Most people want class 1. Most of the mines deliver class 2. So there is a mismatch between these two markets. And nickel is so important for the battery industry because the growth of, or a spike in nickel price drives the cost of a cell in a much stronger way than the change, for example, of cobalt, as well potentially also in lithium. And you have here on the right side the results of our cost model that simulates what if the price of nickel would go instead of from 21, which is a reasonable price in the latest years, towards 41, towards 63. And in comparison to cobalt with the same trends. And you see that nickel is much more impactful into the cost of NMC battery rather than in comparison to cobalt, for example. Now, our fourth hypothesis is about technology, and this is a nice segue from what I just described about in terms of NMC and the dependency from raw material, right? So what's the alternative? Everybody, we hear a lot about solid state, as well as silicon anodes. Those are all options to improve performance. But what's performance in the end? So performance normally is seen in terms of, in the automotive or OEMs, automotive OEMs terms. So it's about energy density because it gives the range. It's partially about safety because, you know, it allows you to even make your battery pack lighter or with less safeguards. And it's a lot about cost. But this is not necessarily what all markets want. This is not necessarily what the performance for another market is. And if we take grid storage, ESS, for example, well, cost obviously is very important, but energy density is almost irrelevant because the weight of your battery doesn't determine if it is a good battery or not. Lifetime and power, it's much more important, for example. Not saying that all the other parameters are not important for the two markets, but these are really the two that would drive. So if we think about the future, where the technology will lead us, obviously from an automotive perspective, this will lead towards higher energy density and potentially better cost. So NMC lithium, NMC 811 lithium, NCA lithium, so with or without solid state electrolytes, is most probably the answer for this sector. While for other sectors, for example, grid storage, as well as for entry-level cars, maybe LFP is actually the answer. And that's why we believe that LFP is also here to stay in different declinations, if anything. And if we see how important, again, connecting a bit with the cost of raw materials and how this uncertainty applies to raw materials. So what we see is that we forecast that at the level of energy density, we are going to have NMC more performing than LFP, even without changing towards lithium metal or not as anode. And cost-wise, we are expecting LFP to stay cheaper, but depending on how the nickel price will evolve, this gap could be bigger or much smaller. So this is a very important point if you're thinking about doing a project that is in the long term, because obviously you don't want to buy now a cell at a certain price and forecast tomorrow I'm going to buy it at another, and you end up with a very different cost than what you were expecting.
And let's also look at our fifth hypothesis, at recycling and second life. So what we calculated, what we looked at in detail is the recycling business case. And we saw in the past that companies, OEMs, delivering electric vehicles were putting money on the books because of the obligation of taking back the battery, independent of whether somebody asks for it or not. We are now seeing that for an NMC 811 battery, so with the valuable nickel cobalt, recycling can absolutely become a viable business case if a couple of facts, let's say, are in place. It needs to be a battery with valuable materials like NMC 811. It requires a high utilization of all the investments, so the plants. It also requires, and that's probably a key point, a very sound setup of the logistics actually to go around the high cost of hazardous goods transportation. So one option of doing this would be, for example, a hub and spoke approach, where the powder, the black mass, is actually created in a more distributed setup, and then it's going to be transported as powder, but not as a battery, to central hydrometallurgic and refining processes. So as such, we can see that the recycling of an 80 kilowatt hour battery can be a $600 US positive business case. And how does that now compare with the second life application? So in general, second life is actually a more profitable business case, because we are not destroying the value that has been in the first place been brought into the cell. But the complexity of collecting the right batteries with the right components, then transforming it into the exact bespoke components and batteries that go into, for example, the stationary storage application, that is a very, very complex business setup, where the modular design for the different second life applications is key to actually allow for a very efficient business setup. In the same, or at the same level, also the automation and the high plant utilization are very, very relevant to make this business case that you see here on the lower end actually viable and to make it reality. In other words, setting up a financially viable second life reuse business, second life battery manufacturing business might be an even higher challenge than setting up a sound and financially viable recycling business.
Sorry. Our last hypothesis was all about CO2 emission. How much can you reduce? So the amount of CO2 that you emit per kilowatt hours does really vary depending on where you are, what's your process, what's raw materials that you're using. But starting from an assumption of around 55 kilograms of CO2 per kilowatt hours, which is not far from an average, if you want, or a normal new plant. What we see is that if we use recycled raw materials, and the recycling being done with hydromet technology and a mechanical shredding, you can reduce the emission overall of your battery pack by 36%. That's a huge gap, and it's mostly because all the part of mining is completely removed, while the refining step is heavily impacted, heavily decreased. And this would bring us to a $35 per kilowatt hours. Other levers that you can pull to decrease it even further, and that's what some players are actually looking into right now, is to use a complete net zero production. So using a lot of electricity, try to minimize the amount of energy that is used coming from a different source, as well as moving the electricity from the grid, which is normally a mix, to trying to use a complete zero emission source. That would be hydro plants, or could be solar, or any other, or even batteries that are connected to some wind or solar farms. And in that case, you can bring down, we're expecting in the medium term to be able to bring down all the emissions even further, all the way down to 6 kilograms of CO2 per kilowatt hour. So if you play with all these levers, you can decrease your emission by even 80%, 90%. And this brings me to the end of our presentation.
Fantastic. Thank you so much, Nicolo, Marcus, and Jakub. And let's move swiftly on to a panel discussion. And Dave from Curation is joining us as well for that. Your questions have been piling in. We will have a few minutes at the end to answer those. But first of all, let's go straight into it. So while the cost of lithium batteries has broadly been falling rapidly in the past few years, are there any drivers that might actually slow down that decline and even cause costs to rise?
Maybe I take it.
Sure.
So we have basically three blocks of cost. The raw material cost, which is about, I mean, it depends on the battery chemistry, but it's about 1/3. Then the OPEX and the CAPEX depreciation, and all the utilities like electricity, water, etc. And the OPEX, the CAPEX depreciation, the use of utilities, water, electricity, are decreasing based on efficiency gains, improvements in technology, so manufacturing technology. The only thing that actually stays constant is the raw material cost, or is not compressing, let's put it this way, is the raw material cost, with the only exception that also the use of raw materials becoming more efficient. So also that is declining. And therefore, at the end, we do not see that there is really an increase of cell cost, an increase of battery cost effectively, a little bit independent of the flare-up of raw material prices that you could expect. So the flare-up of raw material prices that we can foresee, that we could imagine, that we put in the models, does not outweigh the improvements that we see in the industry.
Excellent. Okay, thank you, Jakub. So will the EV industry continue to drive innovation and cost reduction in ESS, or is there going to be a divergence? And will cost reductions driven by the scale of the EV market continue throughout the lithium battery industry?
Let me take this one. So I break it down into, you have on one side a question on the driver innovation. So the EV industry will remain the main driver for innovations going forward. The sheer size of it is going to drive this. Yet, what's innovation, and what are the parameters that you want to look into? And in that case, what we see is that while the EV industry will drive on, for sure, cost, energy density, and others, and safety, fast charging, The ESS industry has other parameters, and so that industry will drive on cycle life, on volumetric energy density potential, and even more on cost than the EV industry. Then when we talk about scale and cost, so there is, and we saw it in one of the slides, that there is a benefits to make gigafactories. And being the ESS industry relatively small, you don't have gigafactories that are completely dedicated. It's not a standard ESS complete gigafactory dedicated to ESS. In the future, this can change, because what we see today, that between 16 and 20 gigawatt hours is a bit scraping the bottom in terms of benefits from scale. So when ESS is going to be big enough, the gigafactories will be produced only for that, and will drive on one side innovation and maximize in terms of cost reduction due to scale.
Right, sure, of course. Okay, so I mean, from what you're saying in the presentation, energy storage systems increasingly need sort of bespoke solutions. And big manufacturers like BYD and more recently CATL in China have responded, making ESS-specific batteries. Now, can the battery industry meet these needs with a continued growth in demand that is expected, being potentially in the order of hundreds of gigawatts worldwide?
I think it depends on whether cell manufacturing can meet the fast increasing demand. So we were seeing that's about 30% year-on-year growth. And we were also seeing that the dominant markets for the coming years are passenger cars, are commercial vehicles. And then about 1/10 of the market is going to energy storage solutions. So in Europe, that actually also means, now looking at the Europe case, can all these suppliers who now, or the manufacturers of cells who now enter the market, who now build gigafactories, deliver on their plans? And looking at this 30% growth, I believe it's very hard to project whether this is going without any hiccups, whether always the supply is going to meet the demand. And we can expect that there are temporary constraints on the market. And if the market is then squeezed, it is likely that the off-takers of cells with the very large contracts, with the very large off-take agreements, are going to be prioritized, and therefore for any of the applications, be it that are not actually having those large off-take agreements, be it stationary storage, be it off-highway vehicles, be it maritime applications, there could be a temporary constraint in supply.
Right. Okay. So supply follows demand, but obviously in any growing industry, there will be some of these sort of kinks and dynamics, I guess. So we were looking at the growth of LFP, lithium iron phosphate batteries, and there's a lot of questions on this from the audience. So perhaps we'll be able to answer some of those audience questions with the next one here. But I've had a lot of discussion about the technical pros and cons of LFP versus NMC and other subchemistries. But what are the dynamics in terms of costs and cost reduction? And we also see LFP batteries could be used for some EVs. Is this a trend you see coming more and more, and could this have an impact on supply chain or other aspects of the ESS industry?
So let me take this one. Yes, we see a lot of, almost every automotive company is now announcing that they are going to use LFP for their entry vehicles. And why is that? It's mostly because of cost. And for LFP, the advantage of LFP is that the material LFP, the cathode active material, is actually cheaper than NMC, way cheaper than that. So of course, so the bill of raw materials becomes an advantage for it, and it will remain in the future. At the same time, the energy density is lower, so you have a bit of a higher cost of all the other components. So lower voltage is lower, but all in all, you have, and that's something we saw, higher performance in terms of cost, lower performance in terms of energy density. So it's actually quite good for an application like entry-level cars.
Right, sure. And a bit of a follow-up question, if I may, on this. We've seen in the US that there's been some utilities that are procuring energy storage, stipulating that LFP batteries should be used rather than anything else. I mean, are there any other major factors that aren't necessarily relating to cost that come into play in that sort of race of chemistries, if you will?
Absolutely. So you have on one side LFP, obviously it's less performing in terms of energy density, which is not important for ESS. So if ESS is focusing mostly on cost, there you go. You have a better performance in terms of cost for LFP, and that's why you want to go there, right? And we completely agree, actually, on this from this point of view. LFP is also better from a safety perspective, and that's something that you might or you might not consider for an ESS as an important factor or not. And if done in a certain way, can also deliver a longer cycle life than NMC, especially high nickel chemistry NMC. So those are all parameters that indicate LFP could be better. In history, we haven't seen so much LFP in that market, mostly because of market dynamics. So some players were pushing other technologies rather than the best technology was actually used.
Okay, and here's another one that a lot of the audience, I think, were asking about. So, hope we can preempt some of those. What are some of the other major technological changes or innovations that might disrupt the battery industry in the coming years? Now, I'm sure there's lots of things, but I guess if we could just focus on some of the main sort of near-term priorities, I guess.
Yes, absolutely. So for sure, lithium metal with or without solid electrolyte, and silicon anode with graphene, not graphene. Well, we have to see that are the main technological changes that we see coming in the short to medium term. Okay, and I'm talking about short to medium term, not 2040 and so on. And these are definitely going to increase energy density. Hopefully, at least in the medium term, also decrease cost. But obviously, it's not only about lithium-ion, right? It's not about lithium-ion technology. There are also some other technologies that are out there, and they might disrupt or even push the lithium-ion industry, and that could be redox flow or sodium-ion. Sodium-ion, we hear that it can be used in tandem with lithium-ion, so it might even increase electrification and boost the demand for lithium-ion rather than take away part of the market. Then I would like also another point that I just keep an open mind about technological innovations. There are also other technological innovations that are going to impact the value chain. For example, new ways of extracting lithium, the adoption of cheap HPAL for nickel. Those are all innovations that might boost the supply of raw materials at a reasonable cost, therefore allowing for the industry to grow and to thrive. So also these are important innovations that might push, if not disrupt, if they don't come, obviously, the battery industry.
Right, okay. So, but I mean, I guess for today, the market of what's actually being deployed and procured is very much, majority sort of lithium-ion focused, as the technologies are, and sort of refining within that. Okay, so presumably the many lithium-ion gigafactories coming online in the next few years are going to continue to drive the cost of finished battery products downwards. Europe is already working on this. The US is a little bit further behind. But how is this growth sort of factored into the cost curves modeling? And, what's really the impact of scale, but then also other sort of cost factors you can differentiate in terms of, where things are being produced, I guess?
We are basically differentiating between location-specific and location-unspecific cost factors. And we're performing sensitivity analysis around those cost elements. So on location-specific costs, labor, electricity cost, construction costs also very much differ. They're factored in the model, and certain geographies have advantages. These these elements, these location-specific cost factors, drive the decision for where actually manufacturers build their gigafactories, despite elements such as public support, of course, also drives decisions. And key criterion is where the demand is. So gigafactories are being built at least on a regional scale close to the demand. Despite the operational efficiency and the yield rates, is then scale one of the most important location independent factors that we see. But Nicolo was already pointing at it. It reaches a certain saturation above 20 gigawatt hours, and then it's really going into, let's say, flat saturation from 60 to 80 gigawatt hours annual production volume.
Okay. And, one of the other things we looked at, we've looked at Energy Storage News, and your presentation touched on this, is that the EU is introducing regulations around the sustainability of batteries in the next few years, including requirements for recycled content, limits on the amount of critical materials like cobalt, as well as greater transparency in the supply chain. So do you guys feel, broadly speaking, that the industry faces challenges in adapting to requirements like these, especially if other regions bring in similar rules?
Yeah, maybe I take this one. I think sustainability for batteries is going to be a key criteria, and it's for once it's the regulator, as you said, Andy. The EU is looking at making the rules and regulations around what can go into a battery and how this has to be labeled much more strict. But I think there's also a push from customers to reduce the carbon content and increase the sustainability of battery making and of the production of the raw materials that go into batteries. So, for example, we see car makers quite clearly defining criteria for upstream emissions, so that they, when they do life cycle assessments on their products, can say that the battery does not contribute too much to the overall CO2 emissions of the car. And in fact, it's quite important if you look at the CO2 emissions from an electric vehicle. Of course, leaving aside the electricity production, which is not in the influence realm of the car maker, the battery is the largest share of CO2 emissions that the car carries with itself. And we are all aware of the issues around cobalt mining and lithium mining upstream. So sustainability will be a key criteria. In fact, I think the EU has set quite ambitious rules there, but it's by far not the only region. We have quite stringent limitations or regulations around this in China today already. And we think this trend will continue. In fact, when we look at it overall, and Nicola alluded to it, if the whole value chain becomes more circular and is better in how to recycle but also reuse batteries, it can actually alleviate some of these pains, of some of these growing pains of the industry, and can lead to a better positive outcome overall. But that requires that we think a bit differently about how we source materials, how we design products for reuse, how we organize logistics. As we've shown, Second Life can make sense, but you need at-scale logistics. You need to prepare for that from the get-go. So it's an exciting opportunity, but one that requires more work and will definitely shape the industry in the next few years.
Sure. So an inevitable and necessary challenge, really, I guess, in many ways. Okay. Well, last question from me for now, and then we'll give the audience a chance, or rather, I'll pick the questions from the audience. But yeah, they've had a chance to ask them. China, South Korea, and to a lesser extent, Japan are leading in battery manufacture today. But as we've said time and time again, growth is expected in Europe and the US. Where else might we see the industry grow? So as you showed, there's a couple of other regions in Asia, like India and Indonesia. So India, for example, is strongly targeting having a domestic industry through policy, and the industry seems very enthusiastic, but it has really yet to take off. So yeah, where else do we expect to see the industry grow, and what are sort of the dynamics behind that?
I think there's a certain scheme. So initially, the manufacturing of lithium-ion cells emerged where the innovation was. And now with growing demand, the manufacturing footprint has started moving where the demand is, and that's because of the scale. And that was China, that is now Europe, that is now also the US. And we see the very same dynamic in other geographies, like in India, like in Southeast Asia. With growing demand, the manufacturing industry, the cell manufacturing industry will also move there. And what you actually need is a viable demand, let's say, in order to fill a gigafactory and therefore have competitive cost footprint. What, of course, can maneuver this, change this a little bit, or adjust in terms of what exactly is a viable scale, is the policy scheme around it. So how about import tolls, etc. And here we also see interesting developments connected to the raw material mining, so that countries who are actually have raw materials relevant for the battery industry available start coming up with policies that increase the value share, that increase actually the share in the value chain domestically. And also when new cell technologies will come available, will come to the market now over the coming years, we consider the same development, the same dynamic, that first we see the manufacturing emerging where this innovation is, be it lithium metal anodes, for example, solid state batteries. First, we see the manufacturing emerging where the innovation is, and then as it scales, we see it moving to where the demand is.
Okay, anyone else want to pile in on this, since it's our final question?
Yeah, sure. I mean, I would just kind of add to that, looking at India specifically, to kind of emphasize the example of demand kind of prompting manufacturing capacity growth. Obviously, as we've already discussed, EVs are kind of the biggest driver of battery development. And in India, we've seen kind of between 2018 and the first half of 2020, the country registered over 500,000 EVs under its FAME policy. This has been amended over time to kind of boost electric two-wheelers, which make up 80% of India's road vehicles, and also represented 97% of EV sales in 2019-2020. They're also looking at kind of spearheading growth through three-wheelers. On the stationary side, India has obviously announced plans for energy storage tenders worth 4 gigawatt hours, and private players like NTPC has also issued calls for 1 gigawatt hour of grid scale battery storage. A lot of people who are looking at building up a manufacturing base are kind of waiting for kind of final approval of plans for production linked incentives worth about $2.46 billion US dollars. And that's aiming to build up 50 gigawatts of kind of advanced energy storage manufacturing capacity over the next 5 years. So based on that, we're kind of seeing some companies already basically laying a claim to domestic production. So Exide is kind of planning to make a decision on a lithium-ion cell manufacturing site by the end of this financial year. Lucas TVS and 24M Technologies is planning a 10 gigawatt plant by, I think it's the second half of 2023. And Reliance is also planning a gigafactory solely dedicated to grid scale battery systems as part of a wider plan that includes hydrogen and some other things. So these are just a kind of a few examples of the trends that we're seeing as part of our work for our clients. But it's just India is kind of one of those places to keep an eye on.
Excellent. Yeah, and I think a lot of our readers found the news about Lucas TVS and 24M particularly interesting. I think because 24M has a really interesting semi-solid electrode technology, which I think could see, kind of if there's an opportunity for India to sort of leapfrog some of the other investments that have been made elsewhere. Okay. Anyway, very quickly onto the questions from the audience, and I'm sorry that we're kind of running short on time here. There were several questions about recycling. So, everyone wants to know about this, and it's going to grow and grow as a topic. So Hugo Radford asks if we're able to give an update on the current recycling capabilities for lithium-ion batteries. And someone else, forgive me, I don't have the name available, was asking how much variation there is from different types of lithium battery cells in terms of what can be recycled and the recoverable value. So anyone like to take that on?
I'm happy to take that. So first one on the technology that is applied. We see, because there would be different options, actually, there would be different recycling technologies who could coexist, but we see a dominance of a hydrometallurgical process, then to extract the raw materials and moving into the recycling chain, very similar to the the refining scheme, very similar to refining of the virgin raw materials. Now, looking into what it actually means if it's a different technology, if it's not an NMC 811 cell that we have chosen to actually show the financially viable business case just in this presentation, it would, of course, heavily impact the overall efficiency of the process if you are collecting many different kinds of cells. And that's why I cannot stop emphasizing that the efficiency, the streamlining of the business setup, that is actually the key to make it a financially viable business, more than the last fine-tuning of the technology of the recovery yields for now. And also on the point that I read in the questions, what about an LFP battery? If we look into the figures that we have about $900 in the case for nickel, about $300 for cobalt. That cannot be balanced out, of course, with the raw materials that we see in an LFP battery. So if we consider that we are having like $1,000 per battery for the 80 kilowatt hour battery less of revenues, that would mean that we are not yet at a positive business case with an LFP battery in this model setup.
Right. Okay. So it's a moving target, really, I guess, to an extent. And I'm glad to see that our audience is really interested in the sustainability and circularity questions, because we had a few on second life batteries as well. So Dennis asked about the business case for second life batteries and whether this is compared to the expected costs of new batteries. And there's a few variations on that question. How bankable would second life batteries be? And also, how cost effective and popular do you think they'll be for grid storage, grid connected and electricity system flexibility applications? So I'm sorry that I've kind of smashed together 4 or 5 questions into one there, but if you could maybe perhaps give us a bit of an overview on the dynamics that you've seen on second life batteries.
Let me quickly start on it. And then my colleagues might add to it. Of course, the second life battery is chased by the declining price of a new battery. And also the recycling business case comes under pressure when we consider that we will use less and less raw materials per kilowatt hour. But it really depends on the detailed look into the exact business setup, whether it's still a financially beneficial situation to actually take back batteries, transform them into second life solutions and market it in order to extend the lifetime of the product.
Okay. Anyone else got a quick note on that?
Yeah, maybe the one thing that I would highlight on this question, about quality of batteries and bankability, I think there's an important role for data and software to play, right? You see more and more companies looking into how to use battery monitoring, remote battery monitoring, traceability of the battery, of the raw materials, but also of the battery in use. And I think if you know up front what kind of batteries you are going to look at, you can make a much better informed decision of should this go into second life, for which use case in second life is it applicable, or should this be a battery that should go and get recycled. So I think we will see a lot of business models and innovation around how can we, what data should we collect, what data should we aggregate, and how do we make best use of that data to optimize the use of a battery across the whole life cycle.
Excellent. Thanks very much. Okay, so time, just one more very quick question, I guess. And I think so Tushar Gampul was asking, into the localization of battery manufacturing, what are the localization trends in components that go into batteries? Things like separators, anodes, chemicals need to manufacture these, etc. If that's something you guys have looked into. And also, if we could get 2 for 1, someone was asking questions about silicone anodes and how competitive that will be. So I guess the question would be how competitive the sort of component manufacturing is, as well as the whole sort of final assembly. Is that one you can take on, guys?
I can take it real quick. Try to squeeze it. We see that as the cell manufacturing followed the EV production, also the active material manufacturing and components is following the production of cell producers. So we see now in Europe popping up cathode active materials as well as others. In terms of technology, so is silicon, there is no silver bullet. Silicon as well as lithium metal are going to be better. So probably they are going to take over the market, but they're not better in every possible way. And that's why we're not going to see them taking right away all the markets because, cost-wise as well as other performance might not be as good. I'm telling one for all power storage. So in terms of fast charging, discharging, it's very difficult for lithium metal solid state.
Okay. Thanks very much, Niccolo. So as you can see, probably each of these questions would be a good sort of webinar topic in itself. They're all so deep, but I think I'd just like to say thank you so much to everyone who's attended. Obviously, thanks to our speakers. Also, I'd like to note that a lot of you did have questions that couldn't be answered, and obviously we have only limited time. But Curation will be following up with everyone who's registered for the call. There's also an email address on your screen there if you've got any sort of follow-up questions. And that's about all to say really from me. And once again, thanks so much to our experts. Thank you to our partners and friends at Curation for working with us. And we hope you've enjoyed this as much as we have. Thank you so much.
Thank you for having us. Thank you, Andy.
Thank you.
Thank you.
Thanks a lot.